Combustion. The word itself evokes images of crackling flames and flickering light. It's a process that has fascinated humanity since the dawn of time. But what exactly is combustion? In simple terms, combustion is a chemical reaction. It's a rapid reaction between a substance and an oxidant, usually oxygen. This reaction releases energy in the form of heat and light. Think of a bonfire on a chilly night. You're feeding the fire with wood, which acts as the fuel. The oxygen in the air serves as the oxidant. As the wood burns, it releases heat and light, providing warmth and illumination. This is combustion in action. Combustion is more than just a mesmerizing spectacle. It's a fundamental process that powers our world. From the internal combustion engines in our cars to the power plants that generate electricity, combustion plays a vital role in our daily lives. Understanding combustion is essential for harnessing its power safely and efficiently. It allows us to develop new technologies, address environmental concerns, and appreciate the delicate balance of energy transformation that occurs all around us. Imagine striking a match. You drag the match head across the rough surface and suddenly a flame ignites. But why does this happen? The answer lies in the concept of ignition temperature. Every flammable substance has a specific temperature at which it will ignite. This is known as its ignition temperature. When the substance reaches this critical temperature, it combines with oxygen in the air, initiating the combustion process. The match head contains chemicals with a low ignition temperature. The friction generated by striking the match produces enough heat to reach this temperature, causing the match to ignite. Substances with low ignition temperatures are considered flammable. These include materials like gasoline, alcohol, and paper. On the other hand, substances with high ignition temperatures, such as water and stone, are not easily ignited. Understanding ignition temperatures is crucial for fire safety. It helps us store flammable materials properly, prevent accidental fires, and develop effective firefighting techniques. Fire, while a powerful tool, can be incredibly destructive when uncontrolled. Fortunately, we've developed various methods to control and extinguish fires, ensuring safety and preventing catastrophic damage. One fundamental principle of fire control is understanding the fire triangle. This triangle represents the three essential elements for combustion: fuel, heat, and oxygen. Remove any one of these elements, and the fire will be extinguished. Fire extinguishers, for example, work by displacing oxygen. They release a substance, such as carbon dioxide, which forms a blanket over the fire, cutting off its oxygen supply. Water is another effective fire suppressant. It cools the burning material, reducing its temperature below the ignition point. Additionally, water can also create steam, which displaces oxygen. Starvation is another method of fire control. This involves removing potential fuel sources from the fire's path. Fire breaks, for example, are gaps in vegetation that prevent forest fires from spreading. Understanding these methods of fire control is crucial for preventing and mitigating fire hazards. It empowers us to react effectively in emergencies and protect lives and property. Combustion isn't a one-size-fits-all process. It manifests in various forms, each with unique characteristics and implications. Rapid combustion is the most familiar type. It occurs when a flammable material combines with oxygen quickly, producing a large amount of heat and light. Think of a burning candle or a gas stove. Spontaneous combustion, on the other hand, is a more intriguing phenomenon. It occurs when a material ignites without an external heat source. This happens when a material undergoes a slow oxidation process, gradually generating heat. If the heat cannot dissipate quickly enough, the material's temperature can reach its ignition point, leading to spontaneous combustion. Explosions represent the most dramatic form of combustion. They occur when a large amount of energy is released in a short period, creating a rapid expansion of volume. Explosions can be caused by various factors, including the detonation of explosives like dynamite or the rapid combustion of flammable materials in confined spaces. Understanding the different types of combustion is crucial for safety and for developing technologies that harness the power of combustion effectively. Section 5, Anatomy of a Flame's Structure and Characteristics, written by Neil deGrasse Tyson. A flame is more than just a visual spectacle. It's a complex structure with distinct zones, each playing a crucial role. At the base lies the dark zone, relatively cool with unburnt fuel vapors. As vapors rise, they encounter oxygen and begin to combust. Surrounding the dark zone is the luminous zone, the brightest part. This is where combustion is most intense, producing heat and light. The outermost zone is the non-luminous zone, the hottest part. Here, combustion is complete, releasing carbon dioxide and water vapor. Section 6. Feeding the Fire, Understanding Fuels. Written by Neil deGrasse Tyson. Fuel is the lifeblood of combustion. It's the substance that reacts with an oxidant, typically oxygen, to release energy in the form of heat and light. Fuels can be found in various forms, from solid fuels like wood and coal, to liquid fuels like gasoline and kerosene, to gaseous fuels like natural gas and propane. The choice of fuel depends on the specific application and the desired energy output. An ideal fuel is one that is readily available, inexpensive, and easy to store and transport. It should also burn cleanly, producing minimal pollutants. While no fuel is perfect, some come closer than others. Natural gas, for example, is considered a relatively clean fuel because it produces fewer emissions than coal or oil. Understanding the properties of different fuels is crucial for making informed decisions about energy consumption and minimizing our environmental impact. Section 7. The Quest for Efficiency, Calorific Value, and Fuel Choices. Written by Neil deGrasse Tyson. Not all fuels are created equal. Some pack a more potent energy punch than others. This inherent energy content is measured by a fuel's calorific value. Calorific value represents the amount of heat energy released when a specific quantity of fuel is completely burned. It's a crucial factor to consider when evaluating the efficiency and cost-effectiveness of different fuels. Fuels with higher calorific values release more energy per unit mass, making them more efficient. For example, natural gas has a higher calorific value than coal, meaning you need less natural gas to produce the same amount of heat energy. Choosing fuels with higher calorific values and optimizing combustion processes are essential for maximizing energy efficiency, reducing fuel consumption, and minimizing environmental impact. Section 8. The Price of Progress, Environmental Impacts of Combustion. Written by Neil deGrasse Tyson. Combustion, while a cornerstone of modern society, comes at a price. The burning of fossil fuels in particular has significant environmental consequences. One major concern is the release of greenhouse gases, primarily carbon dioxide. These gases trap heat in the Earth's atmosphere, contributing to global warming and climate change. Rising global temperatures can lead to more frequent and severe heat waves, droughts, and extreme weather events. Another adverse effect is acid rain. The burning of fossil fuels releases sulfur dioxide and nitrogen oxides into the atmosphere. These gases react with water vapor to form sulfuric acid and nitric acid, which fall to the earth as acid rain. Acid rain can damage forests, acidify lakes and streams, and harm wildlife. Addressing these environmental challenges requires a multi-pronged approach, including transitioning to cleaner energy sources, improving energy efficiency, and developing carbon capture and storage technologies. Section 9. A Balancing Act. Harnessing Fire Responsibly. Written by Neil deGrasse Tyson. Combustion is a double-edged sword. It provides the energy that powers our world but also contributes to environmental problems. The key lies in finding a balance, harnessing the power of combustion responsibly while minimizing its negative impacts. This involves a shift towards cleaner energy sources. Solar, wind, hydro, and nuclear power offer sustainable alternatives to fossil fuels, reducing greenhouse gas emissions and mitigating climate change. Improving energy efficiency is another crucial step. By using energy more efficiently in our homes, buildings, and transportation systems, we can reduce our reliance on fossil fuels and lower our environmental footprint. Developing and deploying carbon capture and storage technologies can help mitigate the environmental impact of existing fossil fuel power plants. These technologies capture carbon dioxide emissions from power plants and store them underground, preventing them from entering the atmosphere. Section 10. Conclusion. Combustion, a force to be reckoned with. Written by Neil deGrasse Tyson. Combustion, a fundamental chemical process, has shaped human civilization from its nascent stages. It has provided warmth, light, and fueled technological advancements. However, the uncontrolled use of combustion, particularly the burning of fossil fuels, has led to significant environmental challenges. As we move forward, understanding the complexities of combustion is paramount. We must strive for a future where we harness the power of combustion responsibly, embracing cleaner energy sources, improving energy efficiency, and mitigating the environmental impacts of this essential process. The future hinges on our ability to strike a balance, ensuring that combustion continues to be a force for progress while preserving the health of our planet for generations to come.